So this week we're going to be focusing on some material from, a little bit of material from your textbook. Some of the chapters we'll cover are pretty short, like today's chapter. It's very short. But it leads into some more technical stuff that's going to be coming up pretty soon in lab with respect to unit tests. So I want to cover the syntax required for that. Provided in your download, the big file at the beginning of the semester, one of the things that you have in addition to ANT, which many of you had trouble with, you had something called JUnit. That's a good way to build, a good library for building test cases, and that's what we'll cover today. But first, let's cover a really short chapter in your book talking about reliability. Because there's lots of ways that we can define quality. We've got a functional component, the functional dimension, and the design dimension. And the functional dimension is the obvious stuff, like reliability. I mean, in fact, it has to work, or our clients are going to be really upset with us. Okay? But there's other things that we can throw down there in functional, like efficiency. If it works but takes forever to add an item to a list or something like that because you didn't use, the stuff you know about order notation correctly, that's not good either. And that's related to the program running correctly, so that's functional. It's got to be usable. Okay, if your client is like a company, it's going to be expected that the software you develop for them is going to be something that their employees can pick up easily and work with. Okay, so those are some of the dimensions under functional, which of course, obviously the most important one, the one we have to focus on first and very early, is reliability. Because if it doesn't work, it doesn't really matter if it was efficient, it doesn't really matter if it was usable. If it's not giving the right answer or it's crashing or whatever the case may be, we got a problem. So even if all of our other functional dimension components are well thought out and work very, very well, if it's not reliable, we have a problem. Okay, but there's more to that than there's more to it than just that, because we also want our software to be well designed. And so some things that we can put down there are readability and reusability. Okay? We certainly, when we're in the process of developing the functional requirements of our software, we're going to have to go in there and make changes to stuff. Okay? Especially if in the process of testing, we encounter some problems. Well, we're going to be most efficient and get the job done quicker if it's easy to read the code. Okay? And we're going to be able to leverage all the software we're working on Project A if we can reuse it in Project B. Okay? So those things don't really relate on the runtime behavior. They don't really make the program give the right answer, but they help us tracking down bugs, modifying code to fix bugs, modifying it to use in a different project, and all that kind of stuff. So we really need to consider both of these when we're developing software, and we're going to try to build into our reliability discussion today, taking care of both of these dimensions. Okay? So, in order to make our software reliable, we need to test it. That's really the only way. We have to come up with test cases. And once we developed a whole bunch of test cases, we have a test suite. Now, unfortunately, that means we're going to have we have got to develop a whole bunch of code just for testing. So we're going to end up with production code, which is actually the program we want to compile and deliver to our clients. Okay? But we're also going to end up with a whole bunch of test code, which unfortunately we're going to have to debug our test cases too. once they get complex enough. The stuff we're going to see today isn't going to be very complicated. Okay? But in principle, the test code can be somewhat complex itself, and we have to maintain it. So unfortunately, having to maintain all this doesn't really get us paid, but it in fact does ensure the quality of the production code in the dimension of quality associated with reliability, okay, which is probably the most important dimension. Okay? But it's got drawbacks. And one of those drawbacks is now we've got a whole bunch of extra code that that doesn't really contribute to the product that our client actually wants us to develop for them. So it's a whole accessory amount of work that we have to do. Okay? But overall, it's probably going to save us time if we spend time on the test code. Okay. We also want to be able to do regression testing. That is, rerun all test cases, or maybe even the entire test suite, after each change. So the test cases must always work. Okay? So if a test case fails, and we're constantly running that, if a test case fails, we have detected a flaw in our code. Okay? Unfortunately, even with the most extensive test suite that we could possibly develop, we can't be 100% sure that we found all the bugs. Okay? The only thing we know for certain is if one of our test cases fails, that I have identified at least one bug in our software. Okay? Furthermore, we really need to automate this. Because if we had to go in there and manually run all those test cases over and over again with input, that would be very, very time consuming, prone to errors in typing in the input. So that's why I showed you all the input files. If you're rerunning your code to find all the bugs in it, simply typing in the input becomes something that in fact you can make a mistake and have to start all over. That's going to be really important for program 1 when I come up with test cases for you, to test your software. If I make a mistake and I'm halfway through all the tests that I want to perform, going back and starting over is just going to drive me crazy. So one of the requirements for your program is you set it up so that I can use an input file, which means you should use an input file when you're writing the thing from the beginning. However, I usually get students that resist me on that, just are stubborn and do not want to use an input file until they come and ask me a question in my office and say, well, come back when you get when you get an input file. Okay? So just go ahead and adopt that now. Save yourself a lot of trouble later. Okay. So it's automated, and that's what we're going to see today. We have to develop code to execute these test cases, but the regression testing itself simply means just rerun all those test cases. So there's really nothing manually intensive. That's after we've actually written the test case itself. Our role is then, for the automated regression testing, is very minimal. Okay? The computer's really happy to do the same thing over and over and over again. We would not be happy to have to do that a million times. Okay, so next bit's pretty important. So in order to ensure that we have reliability, the most important functional component, as well as quality in terms of our design, there's a 3-step repetitive process that we go through when we develop the software. So we're going to write some code. Okay? We're going to write one or more test cases. To test what we just wrote. And then we're going to do a refactor step. And repeat. Okay? So this section in here is meant to ensure our reliability. assuming that we try to do a good job coming up with test cases. Okay? If we're real sloppy with that and our test cases aren't very good, well, then we're really unsure that whether or not we got all the bugs out. But the more times we spend developing good test cases and a suitable number of them, the more certain we are that at least the major bugs are out of our software once we're done and our entire test suite passes. Okay? But after that, in fact, I should put run test again here. Okay, but the three main steps are these three. But after we pass the test cases, we want to take a look at the code that we know now works, okay, at least with our well thought out test cases. We feel pretty confident that our code works now. Can we rewrite it so that it's easier to understand? So modify code to be more readable without changing functionality. Is essentially what refactoring is. Okay? We might see we've got some use of good variables that we should be using that we weren't using, whatever the case may be. We might see that, hey, this should be in its own method, make it more readable that way. And we'll talk about refactoring later in the course. But that's what it is. Yes, my code now works. Is there a way I can clean it up? And then, of course, if you make a lot of changes to your design, that's another way to introduce bugs. Even if all your computations were right before you did that thing, once you start moving code around, you can break it. So really, we should, after we refactor, make sure it still passes all the test cases. Finally, we go back to step one and we write some more code. We're adding on a new feature. Remember, Agile says small distributions. So we'll implement a feature. We'll go through our process of testing and refactoring. Once we think we have that feature the way our client wants it, we'll give it to them. Okay? They may realize that, yeah, this is what I told you, but it's not quite what we really need. Okay? So that's the idea behind Agile. Keep giving them distributions so that they can see what you've got so far and make changes then, rather than at the end, like the waterfall model would suggest. Okay? And then that fits more in with this whole process here. This all goes together. Okay. All right, so I think that we are ready to look at some JUnit code. I may think of something. If I forgot something, hopefully it'll come to me while we're doing this. Okay? So we want to have a library that we can use that will help us create these test cases a lot more quickly. Okay? So that's what JUnit does. It gives you a framework for developing test cases that gets those test cases out there faster than it would be for you to just manually code it. Although that's still an option. Okay? You could literally just write some code that provides input to your program and make sure the output's correct. But instead, we're going to use the framework provided for us by JUnit. And so what that looks like, if I wrote a class called Rational Numbers Test. This has some test cases in it. But there's a couple of things I need to point out first. So there's no main method in here. That's the first thing that you might see. There's a bunch of tests, which JUnit's going to be looking for some keywords that mean something to it specifically as it's parsing your code and finding where your tests are. A test is @test. Every time I have a separate test, I've got that keyword in there. And JUnit's going to run all these tests for me. Okay? But there is, in fact, no main method. So the main method has to exist somewhere. The main method is going to be in one of these packages here. So the reason, well, we'll talk about frameworks later, but the reason why I call this a framework is because this JUnit library is calling our code. Okay? We're writing code. We're not calling methods like we normally do. something else is calling our code. And that's really what a framework is. Okay? So we need to know where that main method is. It's not here because we're expecting something else to call our code. So where is it? Well, I don't expect you to memorize this, but it's here in build.xml. What happens if I double click? It is here. So inside the file, I look in the org folder, I look for JUnit folder, I look for runner folder, I look for the class JUnit core. That has the main method. And then I also need to pass a parameter to that main method that corresponds to the test suite that I wanted to run. So that's in my CSC 2310 folder, rational numbers test. Okay? So you do not have to memorize this. Just know that when you need to run a test suite, come in here to find out. You can copy and paste this whole thing. We'll talk about that probably next time. Okay? But today I want to look at our actual test that we create for JUnit. Okay, where to go? Okay, so I need some imports here, and they correspond to the package, the same package system that you saw with the main method. Not quite exactly the same, but pretty close. So what before means, when we see this keyword, is before each one of these tests is run, we're going to create a new rational. Well, I've got an instance variable up here called rats. We're going to create a new rational number, which is, you may or may not remember, has an array list. An array list of type rational number using generics like we discussed last time. Okay? So that will be done. We'll start up a new test creating a new rational numbers array list before each one of these things down here. Okay? So the most common way to test, there's two statements that my framework will recognize that allows me to do a simple test. And it's assert true and assert equals. Okay? Assert true is going to return, what it expects is a different set of parameters, depending upon which one I use. If I assert true, I'm simply going to have some kind of expression in here that returns true or false. Okay? I will consider if that expression returns true, I pass the test. If that expression returns a false, I'm going to fail the test, and JUnit's really going to give me a lot of output. Okay? Doesn't like it when we fail tests. So I'm going to get a screen full of JUnit complaining about that test. On the other hand, if everything passes, I just get a couple of lines. Almost nothing. Okay? So first of all, we need to give it a friendly name so that we can spot it. If we do fail, when we get this, gigantic list of issues, we can figure out which one of our tests actually failed if we give it, a user-friendly name here. Probably better than example 1. Okay? But in this case, I only provide 2 parameters, whereas in the assert equals case, I'm going to provide 3. And these 2 parameters must be equal. Of course, I can check equality up here as well, like that. Okay? But I can also have any, Boolean expression. Okay? But down here, we're actually going to be testing for equal 4. So it's kind of convenient to have both types of these, depending upon whether you need exact equality, which in fact is a lot of the time, that's what you're checking, exact equality, or if some special test will pass if you've got some inequality. Okay? Let's run that, which it will run all of our tests, and if everything passes, we're not going to get very much output. In fact, here it is. JUnit version 4.12. It took not very long to do all the tests, 0.005 seconds, I guess. And everything is okay. We passed 5 tests. Where the 5 comes from. 1, 2, 3, 4. So each one of those at test things indicates a complete test case. Okay? If I weren't being a little bit lazy here, I would probably have each and every one of these in its own test case. But I doubled and tripled up just to save some space. Okay? But when you get the report back that it passed a test case, that means count up each one of these @test things, and that's the number that you passed or failed. In fact, let's fail. Yes. Okay, you can do that now, but not on the exam. Okay, we get tons and tons. That's probably way too much output for one failed test. So it took 0.006. There was one failure. It was simple test. Okay, that was the name of the test here. And I'm wanting to say, where's my example 1 is the name that I gave it. So all of this helps me giving the test itself a good function name, as well as providing a meaningful first parameter to it, will help you read through all this otherwise, useless stuff pretty much. Okay, to figure out exactly which test failed. And it ran all 5 and it had one failure. Okay, so fortunately we know exactly which one to go to and try to fix. So in this case, it's pretty easy to fix. There's my error right there. But in reality, we'll get to some examples later on that if they fail and I got to go change my source code, my actual program, not a trivial change like that. Okay? Now, we need to talk a little bit about strings. In fact, let me first go ahead and do this, explain what I'm trying to do here, and then do this test, and we'll see, what fails, and then I'll try to explain why. So I've got two strings, A, B, C. I've got an assert true, which I've got to have a Boolean expression here. Okay? Actually, both of these are assert true. So they both have Boolean expressions. One of them calls the equals method, which what that does is it goes through character by character to make sure the strings are equal. Stir1 equal stir2 does not do that. Does anybody remember? I think I mentioned this once. What does stir1 equal stir2 when those things are objects? What is that? Is that a special name?
Does it do a pointer?
Yes. This is the name I want you to use on the test. It's an alias. Okay? When you have two pointers that contain the same memory address, that's an alias. So what that results in, what that looks like pictorially, is that. Okay, so stir1 and stir2 contain the same memory address. That result of that Boolean is going to be true. I'll pass the test. Okay, but notably, these two things are quite different in terms of operation, because calling the dot equals actually goes in there and does work. It compares their characters, which you can see we're going to pass that test. Their characters are the same because they point to the same string. So we're going to pass. Okay? We're also going to pass the second test because they happen to be aliases. They both point to the same object in memory. Let's make sure that's the case. Okay. We fixed our other test, I hope. Yeah. Okay, so this test passed. Now, that works because of the way that I declared my strings. When I declare the first one, we allocate some memory, we put a string in it, that address is copied into string 1. When I do string 2 the exact same way, Java does something different. Because I did not use the new keyword, Java says, oh look, I've already got an ABC defined, I'm going to reuse that address. I'm not going to create a new string, I'm going to reuse one that I already created. And so that's how we end up with the alias situation. Okay? Strings are funny. Sometimes Java will let us use primitive type syntax for strings, like that example. And all the other objects we're going to create, we have to use new. String is, there's probably a few others, but none that I've ever used. String is the obvious exception to that rule. You can declare variables to be type string and not use the new keyword. Okay? So let's do it this way instead. If I explicitly use the new keyword, then this is not going to happen like this. Now I'm telling Java, I want new memory allocated. Okay? And now I'm still going to pass the first test because I'm manually going in there and comparing the characters one by one. But I'm going to fail the second test because they're not aliases anymore. Okay, did I save it? Yeah. Okay, so now it should fail. All right, string equal test failed. So why do I belabor that? Because what's going to happen to you guys is sometimes everything's going to work for you, okay? But when I run your program, it's going to possibly not work, okay? So be very, very careful. In fact, the rule that I would tell you to follow is just never do this. Don't ever use equal to compare strings. Always use dot equals. Then if they are aliases, everything will return true. And if they're not aliases, it's going to do what you probably expected it to do, compare two different strings character by character. Obviously, you compare the same string character by character, you're going to get the right answer. Okay? So we don't want to, I don't care if you declare strings without using new. I do that frequently myself. But just don't do this. Okay? You'll be fine if you just use dot equals to compare your strings. Okay? All right. So that's the special thing that happens with strings that doesn't happen. So now, make sure that I'm back to working. Okay, good. Question so far? Yes?
You mentioned that string 2 becomes an alias for the, it's referring to the same memory location. When you modify string 2, does it modify string 1 there as well? Because Java's doing something string
If we could modify that string, then it would affect them both. But remember, strings are immutable.
Okay.
So the only way I can change that string is to create a new one, copy its contents in, and change it. Okay? Otherwise, yes, it would change. It would affect them both. Anything else? Okay. Let's see. Need to be down here. All right, so now we're going to start testing some rational numbers. Okay? So again, even though I didn't use it, I was creating a new rational numbers for the first test, a brand new one for the second test. I didn't use it in either case. Okay? But really, this class is meant to be testing rational numbers where I may need to use that rats object. Okay, so we'll come down to test our third test, which is rational number test 1. So I'm going to create a new rational number, 6 eighths. 6 is the numerator, 8 is the denominator. And I'm going to add it into my rats variable. I'm going to sum up all the rational numbers that have been stored inside there. And then I'm going to make sure that the numerator for rational 1 is 3 and its denominator is 4. That's because when we built rational number, I didn't want to leave it in this form. We had a private method in our constructor that reduced that fraction to 3/4. So that's what I'm testing here. In fact, it doesn't look like I'm using my rational numbers here either, although we could add a test to make sure that's the case. Okay? I'm testing to make sure that it got reduced correctly. So I give it a 6/8, and then I ask it for its numerator to make sure it's 3, and I ask it for its denominator to make sure it's 4. Okay? In addition, although I didn't do that here, so notice I'm using the 3 parameter thing. If I wanted to use assert true, how would I change it? Well, we need 2 parameters. Rat1 dot get denominator. And if I change this one, well, same thing. Let's leave this one alone. Okay? In fact, I probably should. This looks more readable. But I also want to make sure that the value stored in rats after I added it up is correct. Okay? I only had one rational number in there, so it should also be this stuff, but for add up instead of rat 1. Okay? Because it was the only number that I placed in my rational numbers array list. Let's make sure. Okay, so we passed all 5 tests. Okay? So in fact, let's make sure that our tests are working. Let's force it to give me an incorrect test and make sure that shows up in my output. Okay, good. Okay? So I'm pretty sure that JUnit has some additional asserts, and maybe we can look at that online once we go through here. But the vast majority of the time, you can get by with this 2 variety. Okay? If you need an inequality, you can use this version, but if you want, most of the time you're checking equality, either one will work just fine. Okay, here's another one. And I'm checking the 2 strings in here because I'll explain why. So in this case, my rational number is 6/4. Now what I'm testing is I've got an algorithm in there that when I ask for the 2 string of my rational number, I want it to give me a whole number part. I don't permanently store the whole number part, so that's why I have to call these 2 string methods to make sure the text is correct. Okay? It's not permanently stored, it's only stored as part of my, as part of calling the 2 string method, I convert it to a whole number in fractional part. Okay? So of course that's 3/2, which is 1.5. So I want my output to look like that. Okay? So now this is going to be a string. I don't permanently store that whole number part. But anytime someone asks for the 2 string for that rational number, I'm going to give them the whole number part, the whole number format. Okay? So I got 6/4 going in, which is going to be stored as 3/2. We're going to reduce it. And I sum up again, and I'm making sure that my add, again, I added it to 0. So it should still just be the 6/4 rational number. Okay? The fact that I called sum up doesn't do anything because it's the only number in there. So I'm correctly comparing strings using dot equals. So I call add up and I get its 2 string, and I compare it to rat 1's 2 string. They should be the same. There was nothing else to add to the rational number. Okay? And then I give it a pretty complete name here, so in case it fails, I can find it. I know which one it's talking about. All right. So other ways I can do that, I can provide the 3 parameter version. I can, if I want, make sure that the numerators and denominators are the same, which actually that's a little bit misleading. They're going to be stored as 3 and 2 and not 6 and 4. Okay? So there's several things I can test for that particular operation. The most complex dealing with the actual 2 string output that I generate. Okay? And we continue on with this. Now I'm actually adding some numbers together. I've got 2 rational numbers, 4/3 and 3/4, which, also I've got a third constructor that I mentioned, but I don't think we did much with. I allow my rational number object, my constructor, to take, explicit numerator and denominator format, but also I want to make sure that it correctly reads in if I give it a rational number as text, that it correctly goes in and pulls out the numerator and pulls out the denominator from that text, okay? Then ignoring the divide. And then, of course, I want to make sure that my rational number that now is no longer adding one rational number to 0, but is actually adding up a couple of numbers to make sure that code is working. So I've got a couple of things I'm testing in here. Okay? So the way that I can test that, this is my result for those two things added together. So I can check that the toString for add up, where I added the numbers together using rational numbers object, matches the output for rational number 3. Okay? And then I use both the 3-argument version and the 2-argument version. So another nice thing about assert equals is if you pass it 2 strings as parameters, it is going to call the dot equals method for you. You don't have to remember what we discussed earlier. On the other hand, if you call assert true, then you have to remember to call, if you're comparing strings, you've got to remember to call dot equals. Okay? So the general rule is any object, including strings, all their comparisons should only be done using dot equals unless you specifically want to know. The question that you're asking is, are these two things aliases or not? Okay. So I'm not exactly sure which lab it is where you start having to write these tests, but you can appreciate now, if you've got a fairly complex project you're working on, you're going to have a whole bunch of these test files with a whole bunch of tests in them. Okay? So fortunately, running them over and over again is not a big deal. If you've set up using JUnit, it's creating the tests themselves that is the difficult part. So not only when you're doing your 3-step sequence do you have to write the code that adds to the production code, but oh, by the way, now you got to come up with some test cases. And you have to have the discipline to do it then. Don't wait till later. Your test cases will not be nearly as good once you've moved on and are thinking about some other computation. You say, oh yeah, I got to do a bunch of test cases now. You're not going to come back and do nearly as thorough a job with your test cases that way as you would have if you did it right afterwards. Okay? So that takes some discipline, which, to be honest, I don't have. So I'm going to go in after the fact and probably write a bunch of test cases for stuff that I did a while ago. Okay? But to do it correctly, you would want to repeat that 3-step sequence over small sections of code. So constantly be writing test cases for small changes that you made. Then your test code will be almost as big as the production code, but it will be thorough. Okay, so if you do ever insert a bug into your program when you're making changes, adding new features, you have a high probability that it will be detected. Okay, so do as I say and not as I do kind of thing. Questions so far? Okay, so that actually did not take very long. I didn't think it would. So let's go ahead and now take a look at our batch file and see if there's anything we can. So today's goal is to get through, instead of having the batch file and the XML file being these complete mysteries, let's look at them and try to figure out exactly what they're doing. By the way, let me make sure that I didn't introduce any errors. Did I fix that one? Yeah, I guess I did. All right, so let's start with the batch file. Send to, okay, fine. Do it the long way. Okay. So what happens in the batch file is pretty closely related to what's going on in the XML file. So what I'm doing in there, so you can see I've got a couple of lines commented out. Okay? So they're not going to be executed. So let's focus on, in fact, let's focus on this build one here. So when I tell Ant that I want to build, what that should mean and what we're going to set it up to mean, we can call it anything. We're going to be able to name stuff inside our XML file that, if well named, will identify exactly what task we want Ant to be performing for us. And in this case, I'm going to have something inside my XML file called build. That implies that I would like you to, I want Ant to compile my software, but not run it. Okay? So that's what I'm getting at here, and that's probably where I want to start. Now, eventually, I'm going to want probably to do all of that. I want it, like down here, if I get rid of call for now, we don't need to deal with that just yet. This implies that I want to run it, which may, in fact, require Ant to first build it. So we can tell Ant to build up tasks. Okay? But what's primarily going on inside the batch file is I'm setting up some directory information, and I'm running a particular XML file. So when I say something along the lines of build E, here's what's going on. I'm calling the batch file, not the XML file. So I'm going to be running build.bat, and what I tell it, this parameter E thing, this %1 inside my batch file says that is a command line parameter. That is the first command line parameter provided after the build, the name of the batch file that I want to run. Okay? That's what %1 does. It says fill this in with whatever was provided on the command line. So in our case, E. Okay? Well, a drive letter should have a colon after it. So I am going to append in here so that I don't have to remember to type it into the command line. I'm going to go ahead and append the colon so that we're referring to the drive E correctly in this other stuff. In fact, E colon now becomes the variable drive letter. I've made this assignment. Whatever I type in there, append a colon to it, that is now the variable drive letter. Okay? I want to insert that variable everywhere you see %drive letter %. So I'm saying my Java interpreter is located on the E drive in the Java bin directory. Okay? So when I try to run my program, that's one of the places that will be checked to see if it can find the Java interpreter there. Okay? That's the path. Those are the locations that the operating system is going to check for me to try to find the program that I'm trying to run. So I have to tell it where the Java interpreter is or nothing's going to happen. Okay? I also have to tell it, since I'm running the Ant program down here, I've got to tell it where Ant is. Well, it's in the exact same spot, only instead of the bin directory, it's in Ant 199/bin. Okay? So Ant has its own executable directory separated from where the Java interpreter is. Okay? And then C Windows so that I can do stuff like type Notepad at the command prompt. Now, you can leave the path alone and just append new elements to the path. Okay? I'm just real weird about the fact that I want my environment to be, when I'm running a program, I'm debugging a program or running a program, whatever the case may be, I want everything to be the minimal amount of stuff that I need. I want to be able to list in here exactly the directories that I need and not all the other stuff that Windows is checking for other things. Okay? I want just my stuff to be part of the path. So I'm always going to discard, my command prompt is going to discard the default path information. It's going to replace it with the stuff that I specify here. Okay? So if I wanted to run Notepad, that's why I got to put this on here. Okay? So that I can find Notepad, which is, a Windows program. Okay, so that's what's going on with the path. So now, when I run Ant, the operating system is going to say, aha, I found it in Ant 199bin. Okay, that's the program they're trying to run. But I've got another build here, so what on earth does that refer to? Well, I got to open up the XML file now. How we doing on time? We got time. Okay, and I'm going to find this target thing called build. And I'm going to try to explain all the stuff that it's doing. First of all, so that's ant uses the XML file. So first I got to run ant. Then I tell it I want you to use within that XML file, which is used by default, build.xml, find the section called build. That's the one I want you to operate from. And oh, by the way, I would like to pass the variable that I was calling e colon inside this batch file. I want to pass that to ant. So that's what I'm doing. I'm saying I had a variable called drive letter that I was using in the batch file. I want to copy that contents into a variable used by ant called drive dash letter. Okay? So when I'm using a variable inside a batch file, I want it to be all caps. That reminds me it's a batch file variable. When I want to pass that to another program, I'm going to change my convention for that. Okay? But that's all that's happening here. Dash D essentially means we're passing a variable. Okay? I'm going to give it a new variable name that ant is going to be using to refer to the same thing that was drive letter here. Okay? So we're interested in this one because that's the one we told ant to execute. So it says, there's the name build, so we've got a match. This is the one they want. Oh, it depends on another task, though. Depends on clean. So I got to do clean. So I come up here and I do clean. I want to make sure that everything is recompiled from scratch every time I compile. Okay? The reason is it actually goes back to what we did last time with generics. If I only compile the new stuff that I've changed and not everything, I am not going to see all the generics warnings. Okay, this is going to happen to some of you when it comes time for me to grade generics. The warnings that were present in the files that I left compiled from last time, I'm not going to see them. And so what do you think I'm going to do when I compile and run your program? I'm going to compile the whole thing. I'm going to see your 25 warnings that you didn't see. Okay? Well, if you do stuff like I'm showing you right now and giving you the files for, you won't have to worry. Because we're going to delete everything that was in our build directory. All the old compile stuff is now going to be gone. And I'm going to create a fresh build directory with nothing in it. Okay? So now I'm ready to actually do the build because I've completed the clean step. Clean step means wipe out the build directory or start over from scratch. Okay? And then finally we get to our Java C instruction, which we could have done manually. We could have done, if I want to compile, I use Java C. If I want to run, I use Java. Okay? That probably won't work because of directory stuff. But that's what I would do if I wanted to manually run those things. Okay, maybe next time I can show you how to do that as well. But that's how you realize what's going on in this step is it using Java C. That means compile, don't run. Okay? Notice I have our compiler arg value from last time in here, so that I see all the generics warnings that I may incur as when building this project. Show me all the warnings. Don't say there were warnings. Show them to me. Okay, and that's why we saw let's build it again. That's why we keep seeing these array warnings, because of that compiler arg. Okay, now remember this one I'm okay with. Can't get rid of it. But any others that I see, I'm going to deduct points depending upon how many there are. Okay? All right. So I'm saying where the source is located, it's in the source directory. I'm saying put the compiled files in the build directory, which we just deleted and created. If I don't include this parameter, in fact, it's been so long I don't remember what happens. Let's delete that thing. Something annoying, I think. Yeah, I get some stupid warning, okay, that's completely unnecessary. So that was something I actually had to Google to figure out how to get rid of. So that's everywhere. That's everywhere that we've got to build so I don't have that warning. Okay? And then we've got, so we're familiar with what this does. I'm telling show the generics warnings. And that's it. That's the end of my compile tag. Okay? With the exception of this funny class path thing. So I guess it's time to talk about the class path. What the class path is a list of other locations for already compiled Java code that my program needs. Okay? So if we look inside the Java directory, I provided you with ant stuff, which we're using right now. Okay? I provided you with some JDOM files, which correspond to parsing XML, which we will eventually need in lab. Okay? We don't need it yet. JUnit, we're using those right now. We're trying to run JUnit code. Okay? So I've got some files in here, some directories in here that contain already compiled code that I need for my code to compile correctly. It's essentially a dependency. Okay? I don't have to compile that stuff because it was given to me already compiled. I don't have the source code, presumably, although in some cases I do. Okay? So it's already been compiled. I need to tell, when I'm compiling my code, I need to have pointers to those locations so we can go and find those class files. Okay? Separate from the path that we talked about in the batch file. That's where I look for executables. Okay? They're trying to run some program from the command prompt. Look in these locations. Did you find the executable or didn't you? Okay? Not the same thing. That's why it's got its own special name. It's dependencies with respect to my Java code. Where should I look for them? And so we can see at the complicated stuff at the top, that's, this is complicated, but essentially this is what all this stuff does. It's setting up our class path with the directories to the JDOM files, already precompiled files, the JUnit already precompiled files, and another JUnit. So we got 2 for JUnit and 1 for JDOM. Okay? And so I'm listing those. Here's my dependencies. Stuff that's already been compiled in my build directory. Stuff that's compiled and located in what's called a jar file, which is Java archive. It's a compressed file that's got class files in it. It's compiled Java code. Okay? So go look in there. Here's where it is. Go look in JUnit. Here's where it is. And Hamcrest, that's where it is. So before you give up and tell me that you can't find some class file, look in those places. Okay? So that is what the class, refers it to this name here, which then gives these names, which refer to the definitions that I gave up here. Okay? So it's a multi-step process that Ant goes through, but the net result is look in all those places for already compiled code if you get stuck compiling this code. There's probably a dependency somewhere. Just go look for it. Okay? All right. So now let me change to ant run. We'll pick up with this next time. Ant run just calls this one. This one, run, which depends on build, because when I run it, I want to make sure I have everything compiled, which of course depends on clean, which means I'm going to do a fresh build, and then I'm going to try to run it, and we'll talk about the rest of that target next time.